SOL 6-4, exponents and perfect squares. Positive exponents. A positive exponent is a number that has a base and a positive exponent. Like 6 to the second power. The base is 6. The exponent or the power is 2. And what does that mean? It means the base 6 is multiplied by itself, the number of this exponent. That's how many times 6 is multiplied. For instance, 5 to the 4th power is equal to 5 times 5 times 5 times 5. Notice 4 5s multiplied by itself, and that's equal to 625. It's exponentially large. It is not 5 times 4 equals 20. 2 powers of 10. When we're talking about powers of 10, here's an example. 10 to the 3rd power. The base of powers of 10 is always 10. The expanded form is 10 times 10 times 10. Notice it's 10 3 times itself. Notice the zeros of powers of 10 is the same number as the exponent. Here are 3 zeros, and it's the power of 3. Look for the pattern. For instance, in 10 to the 1st power, we see it's 10. It's 1 and it's 1 0. And 10 to the 2nd power, notice 2 zeros. 10 to the 3rd power, 3 zeros, and so on. 10 to the 0 power equal 1 0. I'm sorry, no zeros, it's just a 1. So when you're working with the powers of 10, the base is 10. If it's 10 to the 4, the expanded form is 10 times 10 times 10. Notice it's 4 tens times itself, and the number of zeros is the same as the exponent. Notice with 10 to the 0 power, it's 0. So it's no zeros. 10 to the 0 power. Let's talk now about zero exponents. When we're talking about zero exponent, the zero exponent rule basically says that any base with an exponent of 0 is always equal to 1. Any base. So a to the 0 power is 1. That means any number to the 0 power is 1. 5 to the 0 power is 1. 10 to the 0 power is 1. A gazillion to the 0 power is 1. A dog to the 0 power is 1. Anything to the 0 power is 1. Now, you go forward and you do the 3 checks for the 3 things that we just did.